So, our next presentation, Powering the AI Revolution with a Global GPU Network, will be delivered by Jesse Eisses. Hope I spelled that correctly. Co-founder of Nosana. Here we have him. Stage is yours, yeah?
Thank you. Sam Altman recently said that compute will be the currency of the future. And this made me wonder, how can compute become a currency if so few people get access to it? When I was at university doing my master thesis at the Deep Learning Lab here in Amsterdam, there was one thing that was keeping the group continuously back, that we were always struggling with. And this wasn't our inspiration or creativity or time, nothing like that. What was always holding us back was that we couldn't get access to the hardware we needed to run our experiments. We spent countless hours in frustration waiting for GPUs to become available so we could run the compute we needed for our research. And this was 10 years ago. In the last 10 years, artificial intelligence has improved by over 1 million times. That is a lot. And it is a lot more than the compute power has been able to develop during that time frame. And it's not just the complexity and capabilities of artificial intelligence that has grown so steep. If you look at the number of models that are being released recently, we can see an exponential growth of what is being produced and what kind of models are being put out there. This graph behind me is the number of open source models put online on Hugging Face in the recent years. And this is only the open source models. There's been a tremendous amount of developments by corporations creating closed source models as well. And we can see that this growth is exponential. So we have the number of models increasing, we have the usage of AI increasing, and we're seeing an explosive growth also in the complexity of these models. This is putting a massive strain on the computational power that is needed to maintain this demand. The hardware needed to run AI, which is called GPUs. GPUs are becoming more scarce, and they're right now becoming one of the most valuable resources on our planet. And this is being felt in the industry as well. Large AI companies are publicly voicing their frustrations and concerns for not being able to acquire the hardware they need to maintain even their current customers. Or worse, they're not able to innovate and develop new AI products in order to stay competitive and release new competitive products. And these guys, OpenAI and Tesla, they are the industry leaders. If these guys cannot get their hand on, they're the kings of the AI industry, right? So if they cannot get their hand on that compute, what does that mean to the rest of us? If we look at the distribution of GPUs throughout the industry, we also see a problem that arises. So as GPUs are this scarce, we live in a time where it means owning more GPUs gives you more power in the AI industry. So we see a massive struggle of large companies trying to acquire as many GPUs as they can. And this is creating a massive centralization of power among these few companies that own the majority of the hardware. In the graph behind me, you see an example of a distribution of the GPUs. And a large chunk of these are owned by cloud providers. And normally, cloud providers would rent out their hardware to smaller companies and people that need it. But in this case, there is often a complete reservation of the inventory of clouds for specific clients. If you look, for example, at Microsoft, they dedicate their complete inventory to ChatGPT, to OpenAI, and powering basically the ChatGPT line of products. And this is an issue because it means that for the smaller players, the smaller companies, there is not really enough power left to contribute to the future of artificial intelligence. If we continue down this path, we're going to see a future of AI that is completely defined and developed by these select few companies. And that is not a future that I want to see or be part of. What we would love to see is a future where all the millions of startups, the scale-ups, the creatives, the hackers, the universities and students, where all these people also are enabled to build new products, train models, do inference, and creating a way more colorful and way more open AI ecosystem. And especially if you look at how important the role of AI is now in our lives already, we think this is incredibly important. So that is why we founded Nosana. Nosana is a new GPU grid that makes GPUs more affordable and accessible for everyone to run AI inference. And we do this by looking beyond the cloud. If you look at historically the production of GPUs, these have mainly been developed for the gaming industry, as they were devices that were very capable of rendering computer graphics. And over the last decades, there's been a lot of devices produced for the gaming industry, and especially the recent models are extremely capable of running AI inference. It is estimated that there are over 300 million GPUs already distributed across the planet in their homes, connected to the internet and connected to power, that can be used to run AI models. That is a massive amount. That's like more GPU power than the clouds combined. And Nosana is enabling that power to be used by companies. We believe that this is the only way to sustain an open AI ecosystem where we can give everyone access to these models. And so that's the product that we're building. So basically what we're doing is we're combining all these consumer devices into a crowd computing GPU grid that is as good as the cloud. There's a lot of advantages that come from this approach as well. First of all, we are extremely distributed, as we have people from over the entire globe connecting their devices to our network. It means that our geographical distribution is very large. We have a lot of different types of devices connected with different attributes. So first of all, there is a lot of different GPU types on our network, and a lot of our devices have their own specifics when it comes to bandwidth, when it comes to internet speed, electricity prices, uptime, and by having that complete set of features that we can use to match to AI demand, we're able to create a really optimal network where we match the right demand from clients and the diversity of AI models out there to the right devices on Earth that can power their needs. And a lot of our devices are gamer devices. We also have a lot of bit more professional grade devices of machine learning enthusiasts that bought like a little rig at home. There's a lot of those. There's also a lot of mining rigs in our network that often have a lot of GPUs in array, but they're no longer profitable. And what they all have in common is that they are heavily underutilized. If you imagine a gamer buying a new GPU because he wants to play the latest AAA game, you're often going to be done with it in a few weeks' time, and then that device will be catching dust on the shelves, while it's extremely valuable power that we can use for the industry. And another thing, of course, that we do is the geographical matching. So if you can match two devices close to you, you have a way more efficient system. And next to that, it's very environmentally friendly. As we're not producing hardware, we're not building and maintaining huge data centers. We're using the hardware that's already been produced and purchased and putting that existing power to work. But maybe more importantly, because of the efficiency and the power that you get from matching the right GPUs to the right jobs, we're able to offer a really competitive price point. The graph behind me compares Nosana to the 3 big cloud providers. And you can see that Nosana is more than 80% cost effective at this specific task, which is the generation of 1,000 images using Stable Diffusion. Stable Diffusion is a popular image generation network that's being used a lot in the industry, similar to DALL-E or Midjourney. So this is a very realistic use case. It's not an isolated example that we picked. And it's a real benefit people get currently from using Nosana. We started our test grid around 10 months ago, and we've been growing really rapidly since. At the moment, Nosana contains over 1,000 GPUs on the network that are available to be used. And we ran over 900,000 hours of AI inference on our grid already. And one thing we're very proud of as well is that we're distributed over 60 countries and 6 continents. So this makes Nosana one of the most distributed GPU grids on the planet. Now, I will take you guys through some use cases on how you can use Nosana today. First of all, I will show a quick demonstration of how a client is currently connected to our network and what kind of benefits they get and how that integration looks like. And after that, in a separate little demo, I will show you how to use our network using our command line tools. This is a bit more of a technical demonstration where we're going to run a state-of-the-art LLM with a small chat UI on top to showcase how a developer or a small company can run a state-of-the-art model in a matter of minutes on our current network. So first off, Sogni AI. They are a very cool AI company that does image generation. I like to think of them as basically Photoshop with a whole bunch of AI inside. So they have a very intuitive interface for creatives on Mac and iPad and the Mac OS devices. And it allows you to generate interactively a lot of different images using a prompt. Also providing a lot of different models that help out. And it allows you to easily iterate and create new images as you go. And when Sogni started, they only had a few users. They basically had some GPUs at home, a few GPUs in the cloud, and that worked fine for developing their product. But as they gained more traction and they started to grow, they obviously started doing a lot of inferences. So we've worked closely together with their team to connect their system to our cloud. And at the moment, we are doing the majority of inferences on their platform. They're happening on the Nosana grid. And I really like this example because Sogni is a product that people love to use in the creative space. It's a very useful tool for creating graphics that people like to use. But like without noticing in the back end, Nosana is powering this product and making it affordable and easier to use for a large amount of people. Next up, I'm going to take you through a little demo of our current product. This is separate from Sogni, so I'm just going to, from scratch, show you guys how you can run a state-of-the-art chatbot on the Nosana grid. We're going to pick a 70B Llama 3.1 model. So that's a pretty large one. We're going to find a nice large-sized GPU to match it with. And yeah, we're going to do some interactions, and I'm going to show you how that looks like. It gets a little bit technical, but it shouldn't be too bad. Currently, the best way to use Nosana is with our command line tool. So you can basically install it on a Linux device, and from there, you can do all the interaction necessary to run a product. In this case, I'm going to first take a look at the markets available, and after that, going to take a quick look at the job definition. Job definitions are technical JSON files that basically contain everything to describe a GPU job. It looks a bit difficult, but we have a whole lot of them that you can use off the shelf, and they're quite easy to set up. So here I'm just installing the CLI tool. That's very simple, takes a few seconds. Next up, I'm going to take a look at the compute markets in Nosana. These are basically the GPUs available. As we're going to run a large model, we're going to pick a large GPU, in this case an NVIDIA A100. And I'll quickly show as well the job definition that I just described. It shows the model. It shows a little UI that we put in top with some Nosana branding, so you can also ask it Nosana-specific questions. And now we're going to post this job definition to the compute market that we just found. This command will run, and it will take maybe a few seconds for the network to match your workload with a GPU on our grid. So some device on this planet is going to pick up this job with a capable device and run it for you. It's already done. What our job definition also did was define an endpoint, which is like a public web URL that we want to access our UI with. That is mainly useful for demonstrating it right now. But as you can see, it spun up a nice UI that might look familiar if you're using LLMs more often. We can ask it questions. We added some Nosana branding. Of course, because this model is based on Llama and you have full control over the hardware and all of the software, you will not be restricted to like the limitations you might get in a AI as a service. So this is completely free and open software that you can remove any censorship or restraints from that LLM and use it in more ways than you could do with ChatGPT. In the meantime, I'm showing here some of the backend of our grid. We are completely open and transparent. We believe that is vital to make an open and sustainable infrastructure for AI. We also supply software that allows you to introspect our grid. You can actually visit this right now at explorer.nosana.com, and it will show you the full capacity of our grid. It will show you running jobs. It will show you the hardware that's available, what you can earn with your GPUs. It's interesting to browse around if you guys want to see more. This is the end of the presentation, but I think there's a lot more to talk about. So if people here are looking for GPUs, maybe you're already running workloads or you want to experiment with some GPUs that are hard to get in the cloud, please come find us. We would love to talk more and learn about your use case and see if we can help you out. We have a booth at B94. We're also raffling a big Lego piece, the Millennium Falcon. I think it's the biggest one you can buy. So if you're not using AI, you can still come by and say hi. If you have GPUs yourself that you want to monetize, we're also happy to chat more about that, because you can do that on the Nosana grid. So definitely come by the booth. My name is Jesse, by the way. I'm the co-founder of Nosana. Thank you very much for your attention.
Thank you so much, Jesse. Very good time management. So that leaves still some space for questions from the crowd. So first question.
Yes, hello. Thank you for the talk. Also, thank you for showcasing how we work with the command line. So very nice. How well would this work in a distributed setting? So now you just showed one GPU hosting a model. So is this possible that I can use multiple GPUs? And what do you do if you have? Do you need the same kind of GPUs then for this kind of job, or can you combine like heterogeneous GPU versions? And second question, how do you handle privacy? So this is like a private person that is pledging their GPU to the grid. So how can I be sure that this person is not recording what I'm asking on the chatbot? Thank you.
Two very good questions. Thanks for that. First of all, our network is more structured in a way that you target a single GPU. So we're really focused on that element of doing inference and doing short running jobs on the GPUs you need. We see that this industry of like using single GPUs for inference is basically becoming the majority of the compute space compared to training, for example. Inference is taking up like a 70% chunk there. So we're really focusing on that specific part. We do have a lot of nodes available with more GPUs. So we have, for example, a lot of mining rigs that have a bunch of 4090s and 3070s. We have a lot of deep learning rigs that have up to 8 A5000s. We have we have H100s and A100s as well, often singular, but sometimes there's more in a box. So you can pick quite big nodes to run things on. Technically, of course, you can cluster things, but it becomes more complicated, and that's not something we solve on a protocol level. And for your second question, that's a great topic. I'll try to answer it briefly because what happens with privacy is on Nosana, there's only one party you have to trust, and that is the node on the other side. You know who that node is. Nodes do have a profile, but you have a trust relationship with that node. Other than that, there is no one that can see that's happening. So there is not like a central party that's aggregating all that data. We believe that's an improvement on privacy. But for really privacy-sensitive topics, you need to trust that node. And we have some solutions for that. For example, some nodes are under NDA and they have specific contracts in place that guarantee privacy. But we tend to work more on less privacy-sensitive data because we offer a really affordable and scalable compute. Cheers.
Perfect. Yeah.
I have two questions primarily based on the implementation. So firstly, when you started off with this idea, how did you actually find your initial set of customers all around the globe, as you said? And secondly, when it comes to these GPUs itself and when it is actually deployed for that particular use case, how do you ensure that the person who is lending it out is ensuring that the system is switched on or working for the entire training duration, for example?
So the bootstrapping phase of the network, like I said, we started 10 months ago and we focused on onboarding a really high quality set of nodes. Like I said, there's a lot of devices now in the world that are capable of running AI, and there's a lot of interest from people to monetize on these devices. So there was no struggle finding initial compute. We really focused on the high quality part and creating a solid cluster of people that have like a really good, stable connection, and that there is also demand for it. And as we're a marketplace, of course, clients are also the people that are purchasing the compute. And we're mainly working now on a partnership basis with some scale-up companies that do a lot of inference, as they're eager to get a good price point for GPUs as they're scaling their business, and we can offer that. And we like to work closely with them and make them really happy. And we have room for more. So definitely, if people are looking for GPUs, come find us, because we would love to hear more about that use case. And the second question about the quality. Nosana has a system. To become a node, you have to stake some value. Basically, you're putting some value at stake, and if you don't perform good, we will take that away. So you're gonna lose money. And we have like an advanced benchmarking system that's continuously monitoring nodes' performances, and that way we were checking if they're doing their work well, if they have the hardware they say they have, and they will lose money if they don't.
Okay, we don't have the time, sorry. Yeah, thank you, Jesse. It was an amazing presentation. Was very insightful. Thank you so much. And as this was also our last session as part of this deep dive tech talk, I would like to thank not only Jesse but also the other speakers. Obviously, I'm sure you will all agree that was super informative, gave us additional food for thought, and. Yeah, just some information. We will also have now a quick break until 4:30 when the plenary session will resume again on the main stage. So you can do some further networking. Maybe Jesse is also still around here.
Of course.
And yeah, thanks for joining us today on this track, and enjoy the rest of the summit.
Thank you.